Good morning. Today is Wednesday, February 19th, 2020. This is the CSA for Unit 4, the study guide. The CSA test is Thursday, February 20th, and we have question 1, solve the following systems of equations. We had a small power outage yesterday, so some students got part A, B, and C initially. So we will begin with the second part, question 2. Before we go back at the end, we'll go back to question 1. Question 2. Linda and Matt both plan to start a club at their middle school. They must each collect a certain number of signatures from the student body to get their club's approval from Associated Student Body, ASB. So far, Linda has 48 signatures, but Matt just started and doesn't have any yet, so he has 0. Linda's collecting signatures at an average rate of 18 per hour. So I'm circling important information that I think is very pertinent. While Matt can get 34 signatures every hour. So 18 per hour, every hour, 34 per hour. And we assume that their rate of collection stays the same. Eventually, the two will have collected the same number of signatures. How many hours will have gone by once they have collected the same number of signatures? Question 1. How many signatures will they both have? Okay, part A, create an equation for each situation. Well, to create an equation, first we need to define the variables. I can see that from up in the information given in the setup, that signatures is a very important thing. They're collecting those. So they're going to have a certain number of signatures at the end. And I noticed that they are collecting signatures at a rate of per hour, and one at 18 per hour, the other at 34 per hour. So I have hours as the other important piece of information. So it would make sense that maybe I call S signatures and H hours. You can use the uppercase S or lowercase s, and the same thing with H. We need to create an equation for each. Okay, so how many signatures for Linda and Matt? Let's think about Matt and Linda. Okay. We know that Linda starts with 48 signatures and she collects 18 per hour. Matt starts with 0 and has 34 per hour. So let's start with how many Matt gets. Matt gets how many signatures? He gets 34 per hour. And for Linda, how many signatures she collects is 18 signatures per hour, but she also started with 48 more. So this type of problem is going to be exactly this, very similar to the one that you are going to get on the CSA. Now we're going to go through this problem, creating an equation. We're going to then, part B, use your equation to create a table for each. Okay, so I'll set that up right in here. Let's set it up as for Matt and for Linda. Matt has S equals 34H. So we need the inputs to be in the left column and the outputs to be in this is the input column, that's the output column. Linda is S equals 18H plus 48. Now you could have done Linda's column here and Matt's column here. So we're creating a table. Now, as we go through, we can start thinking, okay, well, he would start at 0 hours. Matt would have 0 if I put 0 in for H. After 1 hour, after 2 hours, after 3 hours, after 4 hours. We have H and S here. And so we'd have to use the same inputs. 0, 1, 2, 2 hours, 3 hours, and 4 hours. Okay, so after 1 hour, Matt's going to collect 34 signatures. And after 2 hours, he's going to collect double that, which is double 34. 2 times 34 is 68. Now we can see it's also going up by 34 each time. So if I add 34, I get 72 plus 30 is 102. Or you'll have a calculator on the test. You can use the calculator. But if I complete this table, I add 34, I get 136. All right, let's try this one. If H is 0, I'm going to end up with 48 signatures. And then she's adding 18 more every hour. So 1 times 18 is 18 plus 48. 18 plus 48, 58. 66, I believe, right? 58 plus 8 is 66. So again, it's adding 18 every time. So if I go here, add 8, that's 74, 84. Adding 18 more. It's going to be 92, 102. And then add 18, I get 120. So we can already see the power of making a table here, that right at the 3rd hour, Matt and Linda have the same amount, which is what this question at the top is asking. How many hours will have gone by once they have collected the same number of signatures? Question mark. I like to check my work, and I know a table will show me my answer before I get to the next part where I'm going to graph it. Why don't I solve it by substitution? And then that way we can verify our answer. Well, we have S equals 34H and S equals 18H plus 48. So essentially, I can take this solved for S and replace S right there using substitution to verify. Okay, well, let's solve it then. I'm going to take this guy, put it in here. I'm going to get 18H plus 48 in place of S, then the equal sign, and then 34H. Okay, I cannot do any combining like terms. I can't distribute, so I'm left with inverse operations. I have a variable term on the left and the right. I simply need to subtract out an entire variable term from the left and do it to the right. We're actually very close to the answer. 48 equals 16H. Quickly divide by 16, and I get my answer. H equals 3. Well, isn't that what I have here? H3. H3. Things are working out really good. Now I can find S. It's equal to 34 times H. So S would equal 3 times 30 is 90, 3 times 4 is 12, so 90 and 12 is 102. So I've checked my hours, I checked my signatures. I know I'm on the right track to getting a very good score. Part C. So we did part A and part B. Now we need to do part C. Part C reads, graph your equations. Make sure you label your graphs. Well, we're going to need to look carefully at this column as being, this column by ones. This column looks like maybe by tens, by ones, possibly by tens, maybe by fives, but I don't think this is going to be big enough. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we're going to have to go by tens on this side. And I didn't use Y, I used signatures. And on this column, I didn't use X, I used H. For hours, S for signatures. I went by tens. Okay. Now, if I squeeze this at 0 hours and 0 signatures, if I squeeze that at 1, 2, 3, 4, that's going to be really tight. Let's go every other one an hour. So skip that. That's a half hour. 1 hour, 1.5, 2 hours, 3 hours, 4 hours. Now it's going to look nice and spread out. Okay, let's do Matt's in one color, and then we'll do, we can do Matt's list in one color. I'll use pink. 0, 0, 134, 268, 3, 102, and 4, 136. Okay, I need to grab my ruler. Through the origin. There's Matt. Okay, let's do, we'll do Linda then in orange. Here's my values, 048. So she doesn't start at the origin because she had already collected when Matt started. 166. 284. 3, 102, so they hit the same dot, and 4, 120. Okay. Again, grab my straight edge in orange. Notice I stay in quadrant 1. I put an arrowhead on each end. We need to label our solution, which is, this is Linda. Our solution is 3, 102. And so we've labeled everything with signatures, hours. We've labeled the grid lines as being by halves, by tens. And how many hours will Linda, question part D, and how many hours will Linda and Matt collect the same number of signatures? Well, we know that. We want to write complete sentences. Linda and Matt will collect the same amount of signatures in 3 hours. And they will each have 102 signatures. Part E, if Linda and Matt spend 2 hours a day for 1 week, that's 5 days, who will have the most signatures at the end of the week? How many signatures will they each have? So now we have a little bit more difficult question. They spend 2 hours a day for 1 week. Who will have the most signatures at the end of the week? How many signatures will they each have? Okay. So it's 5 days. Let's highlight that. And they're spending 2 hours a day. So how many total hours is that? They're going to be collecting for 10 hours during 1 week. We already have an equation for Matt. We have S equals 34H, which equals 34 times 10, which is 340 signatures. And then we have Linda, and hers are S equals 18H plus 48, which is 18 times 10 plus 48 equals 180 plus 48, which equals 228 signatures. So we have how many? They each would have 340, 228. You can see that Matt has 112 more signatures by the end of the week. Okay. Now we're going to return back to the original problems. Looks like I've got a little bleed through, so I'm going to skip one back. And we're going to finish this up under the question 1. So those people that have had the extra lesson due to the power outage, we already covered this, but for the rest of the classes or absent students, again, this is solve this system of equations. It's an open-ended. We know that there's 3 methods. The methods are 1, graphing, or I should say A, graphing, B, substitution, and C, elimination. When the equations are in standard form, and more than that, when they are additive inverses, we can simply add the equations. We don't even have to manipulate them. So this is definitely easiest solved by elimination here. Sorry, I misspelled that. Elimination. So we're going to add, since they're already additive inverses, that's gone. 10x equals negative 18 plus 58 is 40. Divide by 10, x equals 4. And now you need to pick an equation, 1 or 2. I'm going to pick equation 2. And I'm going to plug in 5y plus 2x equals 58. And I know x equals 4. 5y plus 2 times 4 equals 58. And so I get 5y plus 8 equals 58. Subtract 8 from both sides. Pause the video if I'm going too fast, which is the nicest thing about having a video tutor. You can always pause. I divide by 5. I get 1y equals 50 divided by 5 is 10. And then it asks for the solution to the system. Okay, well, I always write my solution as an ordered pair with x first, comma, y. Okay, we're going to jump here to C, because when I scan a problem, I want to look for the easiest to solve. And I quickly see these were both in standard form, lined up, additive inverses, so elimination was obviously, to me, the easiest choice. Here I have one equation solved for y, and an equation in standard form. So I'm going to take this value of y, and I'm going to substitute it for y, and that's substitution method. Which method did you use? So I'm going to use substitution since it's already solved for y. I'm going to rewrite equation 1. It's 8x plus 5. And in place of y, I'm going to put the value of y from equation 2. Negative 4x equals 24. Put a little dot there to make sure. I'm going through PEMDAS now. PEMDAS. Parentheses, well, yeah, but nothing inside the parentheses, no exponents. Multiply and divide is next. Okay, well, there's definitely a multiplication. A lot of people want to try to add there, or they do some other kind of distribution. It's not. It's multiply here, one step at a time. Remember, positive 5 times negative 4x. Don't drop your variable. Now we have like terms here. So we're going to combine. Combining like terms. 8x, the coefficient is 8, minus 20x coefficient. We're going to combine the coefficients. We get negative 12x equals 24. Now we can do more inverse operations. We divide by negative 12. And we get 1x equals negative 2. Now I got to pick an equation. Well, equation 2 is already solved for y. Okay, I substitute in for the x. It's negative 2. Negative 4 times negative 2. Again, the parentheses. There's no other sign here. That's multiply. Positive 8. All right. And now we are to the next one, the last one. Now I've taught you when we use elimination, this problem set up pretty easily for elimination. You could just subtract the two equations and you would get 0 equals 0, negative 10 minus 10 would be negative 20. I also showed you, okay, well, we can multiply equation 1. We're not going to change it by 1, and multiply equation 2 by negative 1, and then we can add them together. What do I get? I don't change the first one, but the bottom one, by multiplying by negative 1, the signs are going to change. Negative 3y, negative 8x. Negative 1 times positive 10 is negative 10. Now I'm adding them. This is 0y, 0x, negative 20. I'm going to add negative 10 plus negative 10 is negative 20. I end up with 0 equals negative 20, and I know that's false. If I get a false statement, I end up with no solution. And this method that we used here is elimination. There are other methods that you could have chosen for this middle column, and that's why I wanted to show you one method. Another method would be you could just simply solve for y by dividing each equation, 1 and 2. You could divide it by 3, and you would end up with equations in slope-intercept form. You'd see that they have the same slope, 8/3, 8/3. So if they have the same slope, two different y-intercepts, that would be parallel lines. Also shown like this. It's still no solution, but that would be a graphing method. It's up to you to show which method. Okay, let's finish this up with our essential questions. We're going to start with the regular class essential questions. Here is essential question 1. What does the solution to a system of linear equations represent? And what are the three methods of solving the system of equations? And describe the methods for each solution. At the start of the unit, you were handed the answers to these essential questions. And so we had two cycles. What does the solution to a system of linear equations represent? In cycle one, we did them graphically. We graphed each line, and then the solution was an XY, where the two lines intersect. So those are key points here. Your answer is first part graphically at the point XY where they intersect. In cycle two, we did them algebraically. Okay, and they're still in XY, and you can plug them back in, they satisfy the equations. Question 2, when is each method for solving a system of equations most efficient? This question's been changed just a little bit, where it says, what are the three methods for solving a system? And then describe them. Well, it's essentially the same. Just forget about the efficiency part. And you could talk that oftentimes we use graphing to solve when they're in slope-intercept form, when both. We use substitution usually when one equation is in slope-intercept form and the other one's in standard form. And then we use elimination when both equations are either in slope-intercept form, but more importantly, when both are in standard form. That's the biggest key. Definitely lean towards elimination when they're both in standard form. Okay, that finishes the essential questions for the Math 8 class. Periods 4, 5, and 6 for my students. Unit 4 essential questions for the enhanced class would be seen here. What does the solution to a system of linear equations represent? It's still a similar answer. The solution to the system of linear equations is the point of intersection xy on the graph or the ordered pair xy that satisfies both equations. And you can give it in context. And what do solutions of a system of linear inequalities represent? Now this is exclusively for enhanced, so these orders enhanced only. I'll put a little circle or star. In the case of the inequalities, there's a solution at any one of the points in the shaded region. And there's a lot of those. There's an infinite number of them. So any point x, y in the shaded region. So this was, I told you at the beginning, this handout had a little bit, these are not in order. But they will be in order when they're, well, on the CSA they'll be given these 4 questions. And it's important to understand the different methods of solving systems of equations and inequalities. Okay, so make sure you can just justify your solution. For example, you graph when both equations are in slope-intercept form, substitution when at least one equation is solved for a variable or in slope-intercept form, and elimination when both are in standard form. And how can systems help you make sense of a situation and determine an optimal solution? This leans more again towards the regions and the inequalities, but you can reorganize variables in a linear equation, and you can provide solutions in a variety of ways: graphically, algebraically, tables, and verbally. And you can also find one, multiple, infinite, or no solutions in linear systems and inequalities. And you want to interpret the answer in context. In the case of our CSA practice, we did signatures and hours. In inequalities, if there's an optimal solution, it will be one of the vertices of the shaded region. That is the biggest difference between the regular class and this class in enhanced. In the case of linear inequalities, if there is an optimal solution, it would be one of the vertices of the shaded region. Optimal solution. Okay, the CSA is tomorrow on Thursday, so good luck.